So we're back again, and a reminder, if you look at the bottom of the video on YouTube, open up the description there, and it's got the index of what we're doing now. It's got links out to our big composite index that's like 4.5 years of stuff. And it's also got a link to the previous ROS agriculture stuff I started indexing. And I've got a link out to our YouTube page with all the videos on it. So you can dig through all that stuff, and hopefully it ties together. So I guess what I've been doing this week, I keep collecting parts to do my Raspberry Pi power sequencing, and I've got that board like Al has. Let me switch my view here. I got one of those boards that's uh, puts out 5 volts and 5 amps, and he's running a Raspberry Pi 5 with it. I've got a Raspberry Pi 4, and right now I just simply got a fuse on it and some connectors for a battery, and it's got a USB-C connector that'll plug in either to a Pi 4 or a Pi 5. So I've got that. And in order to switch that, I was going to build some transistor circuits, and I couldn't find my transistors. And I got this little relay module that came from Amazon. Let's see, there we go. It's just a little board that's got a single relay and a couple pins on it, so you can control that from logic. Come on, come on. Anyway, it's just a relay module. I think it's rated at 10 amps, and well, you can run it off logic. So I got that, or I've got, I dug through and found some transistors. There are some PNP power transistors. I was going to try those. And then that little one in there is a little TO92 transistor with trimmed leads on it. That's the only one of everything I got. That's the only one I can find right now. So I just ordered up 200 of those on Amazon. They're supposed to show up today. And I also ordered some power MOSFETs. So I'm gonna try a P-channel MOSFET for one circuit and a PNP power transistor for the other circuit. And then in the meantime, I might just put this relay on to switch it just for development point of view. And anything else on that? I just have to pick a microcontroller board and then figure out, hook up that power converter and figure out how to switch it, and then just do things like that. And on top of that, I might add, here's one of my real-time clocks showed up that I ordered on Amazon, and it's got just a battery on the back, and it's basically the same as these little ones. Here's what one of the little ones looks like. It's just a little module that plugs right onto your Raspberry Pi, and if you plug it on a Raspberry Pi, it ends up looking like this. This happens to be a Raspberry Pi 2. I see the clock, which is back. Okay, the clock is actually over here and just plugged on the end with you plug it on those last 5 pins. It just hangs over the board like that. And then I realized, in fact, before anything even showed up, I realized I was looking at pictures of Bob's Raspberry Pi and Al's Raspberry Pi. I think they both have a Raspberry Pi 5, and it's got the I assume it's the official Raspberry Pi heatsink. So it's got this big flat heatsink on there and a fan. I was thinking, well, gee, that might be in the way if you try to put one of these on. So I started looking at my Raspberry Pi 4, and I foolishly bought this cute this thing that goes on the top, where it's got this big aluminum block out here in the middle. There's an aluminum block that's pressed down against the processor, and it's got these copper pipes that are like some kind of what do you call it, heat pipes. Then it's got a radiator, and it's got a fan on top. And then I was looking at that thing, oh, that's not going to work. So I was looking at it here, and the clock has to go in. See, it has to go on these pins on the end here, and it's got to hang on the inside. And see, I got all that crap there. And there's that flat metal bar right there that's bolted down. And that's going to be, so the problem is right now, I can't slip the clock in between the pins and the heat sink on the top unless I raise the thing up. I thought I could take it off completely and put it back on, but see they got those steel bars that they put on there that holds everything down. And the problem is it has to go between those two. So the thing's actually got to go in, wrong side again. It's actually got to go in between here and hang out inside of there. And then the other problem is that big aluminum block there with the copper tubing in it, that might be right in the way. It's either just going to barely clear, or it's going to be blatantly in the way and it won't fit at all. Or maybe I can put it in and kind of wedge it sideways and get everything to fit. And the other option is I got several options. One, just don't use it at all. Don't put a real-time clock on at all, or just put wires, plug in jumper wires, and then put the board, either the little board or this board, just lay them on the table, just have the wires hooked up to it. That'd be one way. Or I could take this heat sink off completely and put a different one on, because you can buy those little square heat sinks with a adhesive on the back, so you just stick them on top of the processor, and that way I could, if it is in the way, I can just move it over slightly to get the thing to fit. So that's what I ran into for real-time clocks. And the thing was, I had ordered two of those. I ordered four of those on Amazon. And then when I was digging through for my transistors, I found this bag, which was, I had ordered 10 of those years ago and didn't know I had them. So I got those. Those are kicking around too. So it's just a whole bunch of them in the bag. And that's where the sheet of paper came. This is the documentation they gave me, which is far superior to anything you get on Amazon. They actually just made up their own sheet and put a couple of pictures and show you. They're showing you how to stick it on top of the board. And as long as you don't have a heat sink, that seems to work just fine. And there's a bunch of links here that maybe I'll post those in the description or something. And they said what they say for programming, something. Anyway, they're links to installing one of these, and probably if you have two or three links, you're probably better off than just one, because if you have just one, it's probably not going to work, and you won't know why. So let's see, that was pretty much the so back to the point of trying to power cycle my Raspberry Pi. I'm still collecting parts. When stuff shows up today in the mail, I'll have stuff to test out my electronic switches to turn all the stuff on and off, so that hopefully I can get around and do something with that. And for the last couple of weeks, I've been saying, you could take an RC servo and tear it apart. Here I'd taken the back cover off and took the front off and threw all the gears away. That's got the pot sticking out. I was thinking, well, I need to somehow now wedge that board out of there. And when I was digging through for stuff again, I found, here's another thing I found. This is the board out of one of those, and you can see it's got the motor soldered onto it, and then it's got the potentiometers actually on wires here. So this would be a nice one if you're going to move the potentiometer and put it out on your big motor to make it into a giant RC servo. It's going to be easier to get this off than the little tiny ones are going to have the pot soldered right to the board. So you'd have to probably unsolder the pot to get it off there. So anyway, that's just yet another one. This is just simply the guts of an RC servo just taken out. And so that's another reason why I really have no excuse to work on this project, because you just have to unsolder the motor and then solder two pins on there and then plug. So you got the here is one of those what do you call it, IBT2 driver boards from Amazon. They're like, I don't know, $3 to $5 a piece, maybe. I don't think they're as much as 10. I think you can get like 2 for 10 or something. And it's just got a motor hooked up to it. And then I just had it hooked up to an Arduino Nano to test it out. So I take the Arduino Nano off, just hook this board up to it. So take this board and just take the two wires from that and hook up to where the on here, I think it's got a yellow and a green wire coming off this. Those would control it, and then somehow I have to get 5 volts in to keep all the logic and everything happy. So that's just another thing I can try out, and number one, see if that will work. Just how well that work as a speed control, and then if I find an appropriate motor that's got a gear reduction on, I could stick a pot on the end of that and wire it up in place of this pot that's on there. So just clip the wire on that pot and hook it up to just hook that up to the one that's on the motor, and then see if that will work as a, if I take a one horsepower motor and run it off an RC servo board and see if that works. So that's another thing I need to get around and do that. Let's see, what was also on my list here? RC servos, RTC. Oh, for the real-time clock. So then when I was, you can get the little tiny ones in there. Well, it'd be nice if this was out of the package, but it's not right now. But so when you buy them on Amazon or wherever, there's just a little tiny board. Well, here, let me just pull this one off. So on the Raspberry Pi, you can just pull it right off there, and it just simply, a little thing like that. It's got a battery on one side, on the bottom side of it, and then on top it's got the actual chip that runs the thing, and it just got the connector on the side. So that'd be another thing. But the problem is this one does not bring out the what they call the alarm pin. There's a pin they call it. Actually, they call it SQW/INT or something, and you can program the chip to tell it. If I set an alarm for say tomorrow at 8 a.m., then when that happens, that pin will go low, and so you just turn the thing off completely, and then sometime in the future, whatever you got programmed in, that pin goes low, even though the thing's turned off, and that can wake up your main processor to do whatever you want. Well, it turns out on this board, they don't bring that pin out. They just have the power and the ground, and the two I2C pins is all they bring out. And then you get this board, it brings out that stuff plus on the end there. That's not going to focus, but anyway, it's got VCC ground, SDA, SCL, that SQW, and then a 32K, which I think is the 32K hertz signal coming out of the thing. So the whole point is it's got the extra pin to bring out that alarm, so you don't have to try to solder a wire onto the chip and bring that out. And here's the thing where down at this end they added a resistor and a diode. So you say, oh, that will charge your battery. Well, the problem is if you have a standard lithium battery and you charge it, it may explode on you. So you don't want to do that. So everybody's saying the first thing you want to do is pop either the resistor. So anyway, there's a resistor right there. Yeah, this is working really well. Okay, so come on, switch back. There we go. So there's a resistor right there. I can't see the number on it right now, but anyway, you can take that resistor off, or take the diode off, or take them both off, and then you don't have that problem anymore. And this one brings out that pin that I wanted, that alarm pin. And the other advantage is this one has a socket and it's got the larger coin cell on. So for experimentation, that might be a better way to do it. But anyway, I was thinking I could put this on my Raspberry Pi sequencing circuit. So it could go out and, you could set an alarm and say at 8 a.m. tomorrow, or in 3 days, 5 hours and 32 seconds, I want it to wake up. You could do that kind of thing. And it's just a matter of hooking it up, and then I don't think it'd be that hard to use it. So that was just some stuff I was playing with and collecting all the parts for. And let me look at my doc. I had the concept of what do I want to use for a processor? And I thought, well, just for something simple, I can start with a Arduino Nano that's got, come on. Anyway, the Arduino Nano has the USB connector, and then on the back it's got the USB converter chip. And if I want to try to put this into a low power mode and run this, with just microamps while it's in sleep mode, well, that stuff is that converter chip's always sucking power, and people always say take the LED off the board, so you're not powering the LED because you're just wasting power. And then you can also get you can replace that with the Arduino Pro Mini, and it's basically the same as an Arduino Nano. It's just that it doesn't have the USB connector, and it doesn't have that, so there's no adapter chip on the back. So basically you're just down to, it's just a bare chip on the board. It's also got a voltage regulator and a couple other things. And again, you got to take the LED off, but then it's got the pins on the end that what they always called the FTDI adapter pins. And you can buy a little board on Amazon, and this particular one actually works well because you just solder a connector on, and then this will plug right on top. So for development, you plug that on top like that, then hook up your USB cable, and you can program the thing and talk to it. And then when you're done, you just pop that off. And then for actually using it, you just leave it like that, and it just gives you a processor on a board, so you don't have to, solder all the pins to just a bare chip like that. So that's just more things that are kicking ass. That's more parts I'm collecting to try this project. And looking at my pile of stuff here. I had a big story about trying to find transistors. Oh, I think I might have told that story, that I only needed one, and I found one with trim leaves, and finally went to Amazon. I just ordered up a bag of 200, and those are supposed to show up sometime today. Actually, it's a box, a nice little plastic box that's got 200 of these transistors in it. And I ordered some power MOSFETs. So I'm going to try two different types of switching circuits. One that's got the that PNP bipolar transistor, and another circuit I'll try one with a P-channel MOSFET, and see if either or both of those will work. the problem with the PNP transistor, it's probably going to get hot, so I have to put a heat sink on, and the MOSFET shouldn't get hot, so that would be another reason to do that. But I don't have enough experience with MOSFETs. I did looked up some stuff, and it looks like yes, I can probably make it work, especially since it's just gonna be a switch. I'm gonna turn it on or turn it off. But if you're trying to run it fast and do PWM, you have to drive it harder and all kinds of extra little things. So I can let you know more on that if I get that working. I'll make up 2 or 3 circuits. I'll have my relay, and then I have my bipolar driver, and then my MOSFET driver, and I can say here's what they do, and this is how well they worked. And I think that's really that. So basically, I've just been collecting parts this whole time, and that's where I'm at. So I guess I'm done talking.
Bob, you want to go or you want me to go?
No, go ahead, Al.
Let's see. On my end, a little bit of progress trying to get share on here. You should be seeing Slack and
Yes, we are.
I had sort of a bit of a mess on my back porch with the solar panel and the antennas and stuff for my base station, and so I moved. This is a shed, I don't know, maybe 7 feet tall. So I thought, hey, I'll just put my box in here in the corner and the solar panel and the antenna there on the edge, and drilled a hole in the back of that my wife hasn't seen yet. And so got that into a more stable position. And at the same time, I had had an issue earlier about whether there was enough power to run the Raspberry Pi, and was the 12-volt battery big enough. And so I just created a little bit of a way to.
Can you click on that image so that makes it bigger?
Which one? This one?
That one, yeah.
Yeah, I did, and I can, but I was going to go over to the actual. So this is the GitHub repository, and so on a daily basis, this CSV file is uploaded and pushed to GitHub, and I was a little bit surprised that GitHub will actually render a CSV file, so I can just see, hey, there was a posting today, and since the program that pushes this is inside what I call the RTCM server, which is doing the other RTCM correction data, I got high confidence in that the RTCM stuff is working. So if I ever am running my tractor and I lose RTK, and one of the debug steps is the RTCM data coming through, I can, at least know this much, that it looks like it's running correctly. And if I look at these 2 days, it's interesting. Both of these are full 24-hour periods, where this first one was just a few hours, actually. Down to the last 2 digits on the longitude and the last 2 digits of the latitude. And what is there? 2, 4, 6, 8, 10, 12, 13 digits of detail. So that's surprising. I mean, that's good. But it sort of surprised me that it was so close.
Are those actual values you're reading out of your receiver, or did some of your math in between give you extra resolution on that?
This
Was
is
that
taking, these numbers came straight off of the GGA sentence being read from the antenna.
okay? Because there is something in the U-Blocks boards where it says set high resolution mode or something, and it gives you lots of extra digits. So it's probably already enabled, because normally it only gives you like 6 digits, I think, in a normal GPS only gives you like 6 digits, I think, 6 to 8. So
Well,
that's probably already turned on.
yeah, it's factory default. The other thing I would say is, if you're reading at 10 hertz, no, it wouldn't. That wouldn't add, just because you did a bunch of reads wouldn't add to the resolution, would it? So,
I don't think so.
yeah, so that's
And
that's
just
where
another minor point, it gives you the date. You might actually want to include the time when you put it up, because otherwise, in 3 months you're gonna say, "Oh, I had a day where it was reporting the wrong time," and you won't know when that was. So if it's handy, you could add another field that says at this time today. So if each one comes up says 10 a.m. and then the first one you did may not have been at 10 a.m. or just randomly a week from now, something might go wrong and it's going to report it at the wrong time of the day. And that
that's
may
cool.
not, just the fact you can see it every day might be good enough for what you're doing.
It's that'd be a good ad. Um, what else? I think I mean, I've got my board in a better spot, and one other thing that I was debating on. Let me skip back so you can see this. Stop share so it's bigger. Jeff had seen this in my sitting on my desk, and that's supposed to be on there. It was an inexpensive $25. In the manufacturing world, you'd call this an andon board. They just called it an LED warning light. And I was thinking I was going to mount this on my tractor so that I could, you know, tell people. I was going to blink it blue to let people know, hey, it's in autonomous mode. Stay away from that thing with spinning death blades. um, and so I took this out to the yard, and then I took uh, an Arduino Uno with 3 of those NeoPixels uh, lit up at the highest power. You set a power setting between 1 and 255. So, and the sad story is I couldn't see either one of them. So, um, public beware. I'm not sure what I want to do about having a blue light blink. I I did look on Amazon to get the prices for, you know, old school bulbs and bayonet holders for bulbs that you put in a car. And I mean, I could jury rig this and sort of not use the LEDs. Trying to get this back off. There it comes. I mean, I probably have enough space inside of there to get a bulb. I definitely have enough space if I sort of dismantle the whole thing. So I have no doubt that I could, DIY something. I'm just debating on whether I want to go through the trouble of that. And then I would need, you know, each one of these is a power cord effectively, and I'd need to hook those to relays. And so deciding what to do about all that is still on my to-do plate. But I mean, if I got up within like a few inches, I could see these, but you know, sort of 10 feet away, you're in bright light. You're not gonna see anything.
Also, depending what you put behind those, if you put it against, say, like a black surface, they might be easier to see, or just something like that. It might make that better. And you mentioned that you had it set to full intensity. Well, I found that, and I did some experiments one time that I was trying to take pictures of with my camera. I could never see the LEDs on the camera. I finally decided it's because those things use a PWM to control the intensity, and depending how that synchronizes to the the high speed of the camera, you may or may not see those. So if you crank it up to full 100%, you've got a much better chance of it working. And that did indeed help it when I was trying to take pictures of it with a camera.
Hmm.
And I was just thinking here, I've got some pictures of my robot driving around outside. I'll have to go track those down. So it could be that I may or may not have had my flashing lights on it at that point. And if I've got a video of it driving around the yard, we might be able to see, does that work? But then it goes back to the issue of not running the LEDs, because I was controlling those on mine. Even my high power LEDs were controlled by a PWM, so that still might be an issue. So that may not, as long as a person standing there looking at you might be able to see it, but a camera may not see that.
Well,
So I'll try to
irrespective
check
of
those.
whether a camera would see it, can you see your lights in bright daylight?
I think you can see them, and I can. They're not they're not real annoying, and there's a couple of issues on that. They're probably not set at full 100% PWM, and also I'm running them a fraction of the amount of current I can run through them. I think somewhere it says you can put like up to 350 milliamps through them, and I'm closer to like 50 milliamps. I think I'm running just because of the resistors I've got in series with it. So I was thinking next time I have it apart, if I can find my resistors, I can run to a surplus store and buy some, and just crank the power way up on it, and then I can back off on the PWM to control it. So there's more things I could do there. I just haven't tried that.
And do you recall what kind of LEDs you have installed?
Oh, that's those high power 1 watt LEDs that you can just buy them on Amazon. The orange ones are actually 3 watts, and the RGB ones are a 1 watt LED. And as they say somewhere in the chart, it says you can run those up to like 350 milliamps through your LEDs, and they do get real damn bright if you're running a lot of current and a full 100% PWM. They get bright enough. They're annoying to have them on the bench because they're too bright to have in your face when you're doing that stuff.
And so I don't have any recollection. I could look it up, I'm sure, online. I'm wondering, do you have any recollection of what these NeoPixels run from a wattage standpoint?
Uh, no, somewhere it'll tell you that. I think typically an LED that size they want to run like 20 milliamps through them, and since it's RGB, they'll say it's going to be 60 milliamps if you have all of them turn on at the same time, and that way they'll say the entire strip you're going to need X number of amps to run the whole thing. So, but no, I don't know right offhand. But that's interesting that you took that out and tried to view them, because I was still going to take make the thing where I made like a round piece of wood and wrap a strip around it to try to replace the ones I have. But that doesn't sound real encouraging from a viewable standpoint.
I mean,
Although,
go ahead.
although on mine, I've got that strip across the back, that status strip that's just like eight of those things. And outside I can see those, but it's hard to tell, what the color is. I've got the multiple colors on it. So yeah, I do. I guess I already have something that will tell me that. Okay, back to you.
So something like this 1 watt RGB thing is what you've got?
Yeah, I've got those, and I've got ones that are just actually just a single color orange, because I wanted a decent orange color. So I got one of the RGB ones of these, and then I've got a 3 watt orange one that again, none of them are running at the full power, so I don't know, what they would actually do.
Hmm.
Now be careful with these, because if they don't have the heat sink on them. See, you really want to get the boards, because that board is actually, it looks like a printed circuit board, but it's actually a stamped out aluminum thing. And then they attach these to that aluminum so that they'll keep your thing cool if you're running a lot of power through it.
So
So
you think this one I have pulled up here would be a lot of heat?
yes. And they're all going to be a lot of heat. It's just that the aluminum plate spreads that heat out, so it's not so your part itself just doesn't burn up.
This was the one that you're saying will dissipate the heat a little bit better.
Those plates on there, that actually, it looks like printed circuit. Well, actually, the one, looking at the zoomed in version of it, you can see the edge of it there. It looks, you can't really tell. It looks like it might be printed circuit board stamped out, but the ones I have are actually aluminum plates that they've got them on.
Yeah, this one.
Right there. See the back of that? See that's aluminum that they're showing you right there. And then also if you bolt that to something that's metal, then that also transfers the heat into the metal. But if they get too hot, just back the power off, and that's a way to get around that.
Hmm.
So that chart you were showing right there, that was telling you about how much current to put through it and how much intensity you get out of it. And see, they're running all those at 350 milliamps. It says peak forward current is 500 milliamps. That's half an amp through each. And, for an LED, that's a lot of current to be running through an LED. But these are big LEDs also.
I'm not seeing a voltage reference here somewhere when it says half an amp. At what voltage?
Well, the thing is, you don't care too much. You want to put enough voltage and then put like a resistor in series to just limit the current. But these are going to be since these are individual LEDs, they're going to act just like the little ones do. Oh, in fact, on the right there in the title, it says red is 350 milliamps at 2.0 to 2.4 volts. Right there. Yeah, right there in the title. So they're giving you voltages there. Now you got to be careful because you get the big ones that are called 10-watt LEDs. They've got a bunch of LEDs inside in series, and by putting them in series, it takes like 9 to 10 volts to light the thing up. So, but as long as you're running on a 12-volt supply, and you just got a resistance in series to control the current, or you could build an actual current source driver board or something. But anyway, you're just using like normal LEDs.
But
You
you've been
just
happy with a 1 watt LED.
Well, as I say, I can see that outside, and I'm just running a fraction of the power on it right now. So probably if I crank the power up, I think I would probably be happy with that. And that's where I've got the little square metal box, and I've got these on each side of it. Let's see, I can probably I was gonna pull up my website. Let's see my website. Yeah, I was trying to get to my website. I can't remember what it is. As people continue talking here, I'll go search for my website, see if I can find it.
Well, I think that's going to be it for me today. Bob, over to you.
Okay. Um,
Your camera's off, by the way.
yeah, I'm trying to get it back on. There we go. Um, I'm a little distracted. I've got a dog that's afraid of the noise outside. So he's wants to be in the lap, and then he wants to get down and up again. Um, this week, past week, all I did was concentrate on cleaning up everything. I made a sandwich out of plywood and stuffed the cables in there. I didn't like all the bundles up on top interfering, and I was losing track of whatever. So I just drilled some holes in the top and poked them down into that sandwich. I'll see if I can share. I'll hit the share button. Then I hit the screens. And now it's broadcast. Start the broadcast. And 3, 2, 1. Okay. Share my screen. Now, how do I get to my doggone?
So there you go. Now just
There.
open your photos or whatever you want.
Okay. I drilled, as you can see, I drilled holes in the top plate and fed all the cables and power cables down in between those two pieces of plywood. So on the lower right is the powered USB hub. So the power and the USB connection goes down, and the USB goes over to the Raspberry Pi, and the power goes over to the left, center left, where you see that little red piece of tape. And then of course 5 volts is coming in from there. And the camera cable goes down in the hole, back up and into the top location of the USB. And I found that that location is an automatic. It picks up the camera automatically. If I try and do it elsewhere, it doesn't work that way. The USB cable, I tried Jeff's suggestion of plugging it into the second port, and that's not an automatic thing. And so I went back to that.
He meant HDMI cable when he said USB.
Yeah, HDMI, I'm sorry.
So just plugging in the second one and powering it up doesn't work. Yeah, you probably
No.
have to power it down completely and then move it and power it back up for it to detect it. But so
Yeah.
anyway, it worked on my Pi 4, and we now know it doesn't work on a Pi 5.
Okay, yeah. Let's see what else. Oh, there's the sandwich where all the cables. I didn't bother trying to bundle them. I was concentrating on just laying them flat and poking them in there, and then gently kind of pressure to hold them in place. Let's see what else. There's the whole thing. You can see the wheels to the right. Let's see what else. That's another view of it. And the back end. I've made it so that this stack can lift off of the platform. There, you see the white plywood, and that's screwed into some spacers. And that whole unit can just lift off if I disconnect the wires. So the idea is lift that off, put it on the Barbie Jeep, and reconnect the Jeep's motors and things like that. That's about it, I think. I can run a long time on 5 volts, and I noticed that with the camera working, it's 1.3 amps. I haven't checked when I start drawing the motor power, but I imagine that'll be next. For software, I downloaded a servo example, and that works, as it's downloaded. So I duplicated that and for motor control, and then plugged in the motors to ports 2 and 3. And all I did was change the port designation, and that works. But of course, it's the same settings as the camera servo, so the wheels aren't synchronized. So I have to mess around with that. But I think I may have to look into multiplexing the two together, or read the Ada literature more and try and blend those two. I think that's about it. Oop. Yeah, now how do I get back? Okay.
Before you go back, Bob, keep it
Yeah.
there. The lower left, that
Yeah.
looks like a power.
Nuts. Okay. Oh.
It looked like a power usage thing.
Yeah, it's a voltage regulator. So I'm regulating from 12 down to 5.
Oh, that's where that's going on, huh?
Yeah. Let's see, how in the heck do I get out of here? Oh. Oh, well.
You might click on hide nearby photos at the bottom and see if is that.
Oh, yeah.
It looks like you're displaying some kind of map program. Maybe that's part of it.
Oh, there it is. It's showing the location. That's Lawrence Lake, and that's our house. So, okay,
There you go. There you go.
Yeah, that's the 12-volt regulator. 12-volt battery steps down to 5, and it shows right now with the camera operating 1.3.
Nice.
We'll have to monitor that when the motors are running, see how much power.
So he's running that power converter instead of that one that you and I have. So basically it's the same thing. It's just got the display on.
Yep, exactly.
He's got a couple of adjustment pots. I'm not sure what those are doing. I assume it's just One of them's going to be voltage, and the other one might be some kind of current limit too, depending on what,
Yeah.
depending when you bought it, it might do all kinds of fun things.
Yep.
Neat.
So next thing is, if I can get the wheels kind of synchronized, not perfect, but close enough to be safe, then I'm gonna put it on the Barbie Jeep and try and run it outside. But I'll keep my remote shutdown real handy, so when it goes bonkers, I can just stop everything. So that's about all I got.
I'm good.
Okay.
So I found one of my videos on my thing driving around outside, and if Bob stopped screen sharing, or I could probably force him off here if I had to,
Yeah.
I could show my thing here.
Okay.
Here, let me just
Stop sharing. Okay, there.
okay, there you go. So let me see if I can get this to work here. I'll say
Yep.
share screen, and I want this screen. And where's the thing? Okay, share sound. So there is some sound with this, so I'll play this, and it may or may not. The sound may or may not come through. But anyway, it's just a picture of my it's out on my YouTube page. I'll
Oh,
put
yeah.
some description all done too, so you can go watch it. So anyway, there's the and let's see, what's this look like? See if they fix that. Come on. Okay, so my I've got my chat and my participants over the top of, and that used to put gray boxes on the screen. Doesn't do it anymore. So anyway, I'll play this. You can watch it. And you can see on the beacon on the top there, you can see it's
Yeah, flash.
and see it's not extremely bright, but again, and it wasn't a really bright day out either, but you can see it from just sitting there looking at it. And I need to crank that power way up on those, just so they're basically so they're blinding.
Are you remote control at this point?
I believe I was, yes.
Okay. How did you synchronize your wheels?
Well, I don't, because it's got a single motor and a differential on it. So
Okay.
so I've got a forward speed, and I've got I can control the steering with an RC servo.
Okay.
And see, that far away, you probably can't see the lights at all blinking there, but I still think if I'd crank the power up about 10 times, it would be bright enough you could see it. I see I'm talking to myself there.
Looks like you need a snowblower on the front of it.
Yeah. So see, getting this close, you can see the lights are blinking on there, but they're not, overly bright. And I didn't notice. I don't know if I had the status strip on the back at that point or not, and that's the one that doesn't show up well with the camera. Maybe when it's done here, we can. It'll come back around. This might be the time I blew the fuse on it. I came down so it was icy. I came down the driveway and hit it hard and tried to spin a donut, and I blew the fuse when I did that. So we'll see what it stops here.
It had a super tight turning radius.
Yeah.
Look on the back. I'm gonna say
Nope, there's something.
see I don't have the status strip on at that point. So here's where I spin it. It comes around and right there, then all of a sudden I realize, oh, it's completely dead. I walk over and poke at it, and I ended up blowing the fuse because I shouldn't have done that. Shouldn't have been getting cute with it.
Well, but you have a learning about how big a fuse you need in order to be able to do a donut.
Yeah. I don't remember if I had a 5 amp fuse or a 10 amp fuse in there, but whatever it was, I shouldn't have been. And through software you can always back that down too. So, and I thought I've got some nice close up views of my beacon, and they're just blindingly bright. And it turns out, but they're not on my YouTube page for some reason. I have probably buried out in my directory of images somewhere. So let's see if I do this and do this. And I say I'll put the link up to that, and people can dig through that if they want. So, and and if you don't like those, you can always buy the 10-watt LEDs, and those are you got to be real careful playing with those if you're laying them on the table and turn them on and put 10 watts on those things will blind you. So you got to be real careful with those. But those you can also buy them. You can get an RGB one, or you can get them in various colors too to do that. And just keep in mind those LEDs are in series, so you need a higher voltage, like 9 to 10 volts, minimum to get the thing to light up. But on a system where you've got a 12 to you got 14 volts or something on yours, whatever yours is at, you probably got enough overhead there that would work. That would work. Just put whatever you need, or resistors in series, just to control how much current's going through it. And then I was buying those little MOSFET boards on Amazon, and they're way overpowered. They're good for like 40 amps or something. They had 2 MOSFETs on the board, and I think that's what I'm running on my flashing LEDs, and then I just have resistors in series to control the current on it, and that's where I just need to pop it apart and put some more resistors in parallel. I think I've got like 200 ohms right now, and that's whatever I've got. It's not near enough current, so I just need to play with that. So one of these days I have it apart and I have resistors handy. I'll do those experiments.
Good deal. Thank you.
And if I find those other images, I think they were out on. I could probably find them out on the ROS agriculture stuff, because I was showing the pictures there. Otherwise, somewhere on one of my random hard drives, I've got all the images. It was probably on either probably on my camera somewhere. So if I can find that, because that was quite entertaining to see that. Wait, there was one more thing here where I was showing my status strip, and it wasn't very bright. I wasn't even intending for that to be bright at the time. Here, let me pull this one up, and I know I'm not sharing yet. So let me back this up and then share. So share that and do that. And so this is just simply this is the actual status strip I had on the robot. Is that going out? That says, yep, that's going out. So here we go. I'll just play this, and I say, play this. Oh, come on. And I would just simply this isn't the one demo. This, when you first turn it on, it runs a pattern, and then so I probably turned it off and turned it back on there. Anyway, I'd put a piece of paper across just to diffuse the thing, so you weren't looking right into the LEDs. And that's something else you can do on any of these. If they got just a point source, put something over the top. Either get like some translucent plastic, like say, take an old milk jug. If you buy milk in the plastic jugs, that translucent plastic will diffuse fairly well. Or I just had a piece of paper taped over the top that I was using. Let's see, stop sharing. So there's just more things as you play around with the stuff. You figure out, different ways to do that. So here's let's see. Am I still sharing? I don't remember. No, I'm not sharing, am I? So let's say this one I think is this one didn't even have the beacons on it, but I'll play it anyway since I got it pulled up here. So we'll go back to here. And looks like that's working. So if I just play this one, I think this is the one that's entitled the first run or something. It takes me forever because I get it turned on and it sits there looking stupid. And I finally realized, oh, there's another battery inside I had to turn on. So, but this is the first time I took it outside and tried to drive it, and you can just see the various pieces bolted inside it. In fact, right there was a Raspberry Pi in it at that point. So I'm thinking if I open it up, the holes are still there. I can bolt my Raspberry Pi 4 back into there. And I'm just going around showing the various pieces on it. And there's my e-stop. See, I put the LEDs so you can tell the red or green, if it's on and off. And inside it's got the remote control, and it's got a red-green LED on it. See, I'm moving the remote control. It's not doing anything. I can't figure out why. And eventually, I think I eventually say, huh, there's my remote receiver right there. See, it's got a green LED on it. And there's at least two batteries. That blue thing's a battery, and this big one here's a battery I'm turning on. So now it's probably going to run after I turn that on. And this is just on my page. It's just quick little videos I put up. So as I say, I'll put a link out to that. You just heard it go, whir, that was the RC server running. I see it's got the Super 200 on it back in these days. Well, it does have the beacon on it, but it doesn't look like it's lit up. So anyway, that was just another. There are two or three pictures of it driving around. There's one later that says something about driving on 24 volts because I put a boost converter on there, and so there's a few videos of it, but it's nothing really spectacular. So it'll just come up and stop here, but and see, I don't see the beacon flashing at all at that point, but that's the way it goes.
It's quiet.
How did you do your camera and the remote control at the same time?
Well, it was hard because I just had to hold on to the remote control. It's not really all that big, and then I just had the camera. I think it was a camera as opposed to my phone. So I just had one in each hand when I was doing that.
Oh, okay.
And that's why it's not quite as smooth as it could have been either, because I was doing something stupid at that point. So anyway, that
Your remote control, is that powered by a Teensy or what?
well, it's got that Adafruit board. It's like a teensy board, but it's basically just a little board. They call it their LoRa feather board, I think is what they call it. That's got a little Cortex M0 processor on the board, and then it's got the LoRa module. So it's basically like an Arduino with a radio built into it. And then somewhere I've got images of that. I was thinking about well, I've got it right here in front of me. I could go look again. Let's see, I'm not sharing. Okay, so let me back up and say.
So you're using a LoRa radio.
Yes, that's what I'm doing for the remote control stuff.
Okay. Oh, that's interesting. All right, look at that.
And I found out that board that I bought is not what I should have had because I ran out of IO pins on the thing. So how do I get back to my main page here? Let's go back to here. And let's see, here's some pictures of that. Now I forgot what I was going to look for. But this, I was just dumping stuff out here on the internet. It's just like I could point to it and say, "Oh, here's what I did," and it just like a little 20-second video with basically no narration or anything. Oh, here's another one here. Let me come back here and say share this. I said share this. There we go. Okay, we're getting closer. So come there and then come down here. This one here. This is my flashing beacon inside the building. And so you can see see they look fairly bright right there. But you get out in sunlight, they don't look that bright. And I don't remember what the settings were. I've got that. At this point, I was running that PWM board like Bob has, and it's in fact, right here. See, here's the PWM board that's hanging out. So it's got I squared C that goes back to the processor. Then here's 4 of those little MOSFET boards that I bought on Amazon they're rated at like 40 amps each or something. And then these, I think, are some big resistors I had on the thing. So I might have been driving higher power at this point that I ended up with in the later stuff I was running. So we'll let this run, and then I'll play the whole thing again so you can see how bright the LEDs are. So eventually I put all that stuff down in the box down where the battery is. So I'll play that one again. And so you can see those lights, they look pretty bright, and they probably are brighter at this point than they are on the modern stuff. And I don't know if they're cycling. They look like they're doing something, and I don't know what they're doing. and the other thing, talking about cameras interacting with LEDs and so forth, if we back up to, if you watch right here as I walk around, you can see these weird lines, see these vertical lines on the screen. That's what it does to the camera. It doesn't like what the interaction between the PWM and the camera is why those are showing up. And I guess that's all there is to see about that, because that's the end of the video again. And let me back up, see if there's any more. Why is this so hard to run? Let's back this up. This was we just watched this one. That's the one that didn't work. Here's one with the LED status strip. So that's all there is to that, I guess. So if I get time, and that reminds me, since I looked at that side, I had those giant power resistors on there. It could be that if I just get different resistors to put in the box instead of the little ones I've got in there, that might be an easier way to do that also. But I haven't even torn it apart yet. I need to tear it apart because I've got to put the Raspberry Pi in. At that point, I could tear it all the way down to the battery box where I can get to that driver board, and I could modify that just to see what it's going to do. So I guess that's all I have for this week. Anybody else have anything else?
Good.
Okay.